Good morning, everyone. My name is Eric Romo. I am the business statistics tutor here at Fresno City College, and today we will be talking about confidence intervals. Well, what is a confidence interval? A confidence interval is an interval of numbers computed so that we can be very confident that a population parameter, for example a mean, is contained in the interval. Recall that with sampling techniques that there is always some error we must take into account because we don't know everything about the population. So what we're really trying to say here is that if we do a confidence interval, we may be plus or minus away from the actual mean value. So we use confidence to tell whether or not how confident we are about our statistics. So a confidence level are used to describe the level of confidence we expect for our statistics to lie within that interval. The current general business standards of confidence is 95% confidence, which means most businesses accept that there is a 5% chance that you are incorrect with your calculations. These are described in our calculations as our confidence coefficient. Now, confidence coefficient is the probability, before actually taking the sample, that a confidence interval for a population parameter will contain the population parameter. So, let's go back to that value that I said the general business standard is 95%. Well, if I have a 95% confidence interval, then I need to convert that to a probability, which I just divide this 100% to make 0.95. Well, here if we do some algebra, it says 1 minus alpha is 0.95. Well, I need to figure out what 1 minus something makes 0.95, which here in this column tells us 0.05 is alpha. So, I need to take that alpha and divide it by 2. But why do I do that? It's really because with our normal distributed curve, we need to take it from both sides, or a two-tailed test. So, after taking that two-tailed test, which means from both ends, a divided by 2, I get 1 minus alpha divided by 2. So I'm taking this value right here, and I'm subtracting it by 1, or taking the complement, to find the area or probability of 0.025. And so from here, I go to my z-chart, z a divided by 2, and I need to find on the z-chart what value of z will get me 0.975. Well, I went to my z-chart and I found 1.96. So, and the same holds true for these other values. So say if your business wanted a 99% confidence interval, you would have a z value of 2.575. I would recommend that you commit all of these to memory because they will come up over and over and over again, or take a picture, save it somewhere on your computer, because this is a very valuable table that you will use in future statistics. Also, so once we take the z value or z-score right here, well, what do we do with this value? Why is it even important? It's actually because we take it and we put it inside of our confidence interval formula. So, x bar right here is your mean, plus or minus the z-score confidence value. So I wanted a 95% confidence, so I'm going to take that 1.96 and plug it in to this z value right here. I'm going to multiply that value by our standard deviation, sigma, divided by the square root of n, my sample size. Okay, so let's go ahead and put this into practice. A credit card company wants to know if their new billing system will bill customers faster than their previous system. The new system billing time is on average 18.1 seconds, and has a standard deviation of 4.2 seconds. The company wants a confidence level of 95%. What is the confidence interval of the new system if we sample 65 customers? Alright, so lots of information. So the first thing I want to do, okay, is look for these values. So I'm going to put these, I always put my variables out in a little line so I can figure out what I'm trying to look for. So standard deviation and n. So these are all the variables inside of this confidence interval equation. They said on average, which is this value right here. So average and mean is a dead giveaway for the mean value. So I'm going to put that right here. 18.1 seconds. Standard deviation. Standard deviation I know is my sigma, so I'm going to put in 4.2 seconds. They said they wanted a 95% confidence interval. Well, I know from my previous little chart right here that my z value for z alpha divided by 2 for 95% confidence must be 1.96. So this value right here is 1.96. And my sample size n, let's see, what is the confidence interval of the new system if we sample 65 customers? So this right here will be 65. I know everything that I need to know to figure out my confidence interval. So I need to write this equation twice because it says plus or minus. So I'm going to put my mean, 18.1 plus 18.1 minus is 1.96. These are where I'm getting all these values from. Multiplied, I like to put it in parentheses. Let's see, standard deviation is 4.2 divided by the square root of 65. And I just rewrite the same information right below for the minus aspect. 2 divided by the square root of 65. Alright, so I got to do some calculations here. Well, what is, so always do parentheses first. Okay, so I got 4.2 divided by, parentheses, the square root of 65. Close my parentheses, enter. Alright, I got this long decimal of 0.52094. So I got to multiply that now by 1.96. Alright, so I get 1.021. Alright, so that value is going to be for both the plus and the minus. So I'm going to, if I can copy this value, so copy. So now I'm going to add that value to 18.1. So 18.1 plus Control V. Okay, so my upper interval is 19.12 seconds. Okay, so I gotta write this in interval notation. Is it 1, 2? Yeah, 1, 2. 1, 2. Alright, now I need to minus. So 18.1 minus Control V. I get 17. Rounded up, that'd be 17.08. So what is this confidence interval telling me? Okay, remember, the confidence interval is to find or to tell me a level of confidence that I have that my mean right here, or anything else that I'm looking for, is within this confidence interval. And that's all there is to it.